Hi everyone, I'm Anil Kumar. I'm an assistant professor in the Department of Electronics and Communication Engineering at Marri Laxman Reddy Institute of Technology and Management, Dundigal, Hyderabad. Today we are going to discuss the subject embedded system design. In that, introduction to embedded system design. We're having course objectives in a course outline and course outcomes, course syllabus, that is, we're having R22 regulation syllabus. We're having in this embedded system design 5 units. They are unit 1 is introduction to embedded systems. This all comes under the introduction part for the unit 1 about regarding embedded system design, as well as unit 2. In this, the typical embedded system, and coming to unit 3, embedded firmware. Unit 4, RTOS based embedded system design. In this unit, we are going to discuss about the operating system and how the operating system will be nowadays using by in the electronics. Unit 5 is task communication. These are the course objectives. From these course objectives, the students will try to learn, understand the basics of an embedded system. By using this lecture, we are going to discuss about this subject. Understand the basics of an embedded systems, and by this CO, how the embedded system will works for nowadays in a regular life by using embedded systems, and programming of an embedded system, how the program will be inserted to the system. Designing of an embedded system for different application, how the system is designed for the different type of applications by using this embedded system. Understand various operating systems concept and choosing autos. Understanding the various operating systems concepts and choosing autos. By using this, how the operating system will be understanding to the different types of concept to the embedded system design, and how the autos will be choose for this embedded system design. We are going to learn this outcome. Design, implement and test of an embedded systems. How the design will be there, how the implementation will be there, and how the testing will be there for the embedded system design will come to know in this subject. These are the course outcomes. Understand the process involved in the designing of embedded systems. Learn basics of OS and autos. Operating system, that is OS stands for operating system and auto stands for real-time operating system. Understand types of memory. Understand the embedded firmware and design approaches, and gain the knowledge on task communications. By these course outcomes, understand the process involved in the designing of embedded systems. How the embedded system will be designed, there we will come to know in this CO. And second one is learn basics of OS and autos. How the basics are there in the embedded system by using OS and autos, we will come to know in this course outcome. And understand the types of memories. How many types are there in this embedded system? What are they? We will discuss in this CO. And understand embedded firmware design approaches. Understand the embedded firmware design approach. Firmware means it is a software. And understand the embedded software designing approaches, how that will be implemented in this embedded system design. We will discuss in this course outcome. And last one is gain the knowledge on task communication. How the drivers and all others peripherals, external peripherals connecting to the embedded system, we will discuss in this course outcome. We are having syllabus for this embedded system design, R22 regulation. We are having 5 units. First one is introduction to embedded systems. In this, we're having the topics: definition of embedded system versus general computing systems, history of embedded systems, classification, major application areas, purpose of embedded systems, characteristics and quality attributes of embedded systems. These all are comes under unit 1, that is introduction to embedded systems. Coming to Unit 2, the typical embedded systems. In this, we're having the topics are core of the embedded system, general purpose and domain specific processors, ASICs, PLDs, commercial off the shelf components, that is COTS, memories. We're having the memories ROM, RAM, memory according to the type of interface, memory shadowing, memory selection for embedded systems, sensors and actuators, communication interface, onboard and external communication interfaces. These all are comes under the Unit 2. And coming to Unit 3, that is embedded firmware. In this, we're having the topics are reset circuit, Bronet production circuit, oscillator unit, real-time clock, watchdog timer, embedded firmware design approaches, and development languages. These are comes under the Unit 3. Unit 4, autos based embedded system design. In this syllabus are covered operating system basics, types of operating systems, tasks, process and threads, multiprocessing and multitasking, and last one is task scheduling. These are covered in Unit 4. Unit 5, task communication. In this, we are having the topics are shared memory, message passing, remote procedure call and sockets, task synchronization, task communication and synchronization issues, task synchronization techniques, device drivers, and how to choose an autos. These comes under Unit 5 task communications. These are having the syllabus coverage for the Unit 5 units. And these are the textbooks we can refer. These are the reference we can refer for the embedded system design subject. Coming to introduction, embedded system. First, we have to discuss about the system. Definition of a system is: a system is an arrangement in which all its units assemble, work together. System is nothing but an arrangement in which all units assemble, work together according to set of rules. It can also be defined as a way of working, organization, or doing one or many tasks according to a fixed plan. For example, we can take a watch. It is a time displaying system. Its components follow a set of rules to show the time. If one of its parts fails, the watch will stop working. So we can say in a system, all its subcomponents depend on each other. Like that, in this embedded system design also, we have to depend on each other. With that, I'm going to embedded system design definition. An embedded system is a specialized computer system designed to perform a specific task within a larger system or a device. Embedded system is nothing but a specialized computer system designed to perform a specific task within a large system or a device. These subsystems are often hidden from the user. These subsystems are often hidden from the user. It cannot be visible to the user. It is inbuilt to the user for a system or else a device, with their functions predetermined by the larger device or system. They are integrated into the system. What we are saying, the functions predetermined by the large device or system, they are already integrated into the system or a device that is not visible. Earlier what we said, that is not visible to the user, that is inbuilt in the system or else in a device. They are typically composed for a combination of hardware and software tailored or their specific purpose. Initially, the embedded system is nothing but the combination of hardware and software for a specific purpose. What we said here, they are typically composed of a combination of hardware and software tailored for their specific purpose only. For example, we taking a washing machine. It is a device. As we said, it is a device. We are integrated or inserted a program into it. As we said, with their function predetermined by that larger device or system they are integrated into. And this is the term integrated or inserted a program into it. We are having by using the washing machine. We are pour the we are inserted the clothes into the washing machine. So we are giving some such time like as 15 minutes, 20 minutes, like that. We are already programmed. After the class wash, after 15 minutes, we have to stop the working of washing machine. After that, we will remove the clothes from the washing machine. Already we are predetermined or else integrated the program to that washing machine. That is, washing machine is a hardware device that is visible to user, and the where software is inserted or programmed into that washing machine. Like that only we are having ACs and microwave ovens and refrigerators and like automobiles. Like all these are, for example, for the embedded systems. ACs were giving some temperature. After that, if the room temperature will be some amount of that will be reduced from the temperature 28 to 30, 32 from there to 18. Automatically, the outside AC unit will be off, the fan will be off. For that purpose, we are using sensor. For that, you are inserting the program for that. Microwave also like that, and refrigerator. They're all automobile units also. We are inserting the program into it. These are, for example, for the embedded system design. In next lecture, we are going to discuss the major application areas of embedded system design. How human beings are used in nowadays. This embedded system design we will come to know in the next lecture. Thank you.